Welcome to this solution of ICSE Standard 10 2025, all of physics paper. But you don't need to see this video if all of these 6 things are true for you. That is, you have solved last year's papers or you think you can. There are a lot of PDF solutions available in many websites. If that is enough for you, great. And if those solutions also tell you the strategy and method of problem solving, great. You know all the techniques, all the concepts, then you're doing very well. You don't need to see this video. But if the answer is no to any one of the above, then you should watch till the end, not for the solutions alone. That is not the focus. Of course, the solutions are there, but the main focus is that you will learn the methodology of solving problems and conceptualization of a problem. That is a key component of the methodology. How to apply those concepts to a problem and basically how to think through. So what are the steps in solving problems? Very simple. Read the question properly. Don't rush through it. Understand it. And a lot of time drawing a diagram helps. Then conceptualize. That is, what concept should be applied, not what formula should be applied. This is wrong. A lot of people do this. And third, set up equations between known and unknown quantities and solve. As simple as that. So a lot of students tell me that they have understood the concept, but they are not able to solve problems. One of the reasons is that they don't follow a methodology. And the second reason possibly also is that they don't actually know the concepts, although they think that they do. So in this lecture, you are going to also brush up your concepts. I'm going to think and you think with me. And therefore you learn thinking skills. So first question from ICSE Standard 10. This is an objective type. You just have to select the right answer. If a body is acted upon by two equal and opposite forces that are not along the same line, what will the body do? Well, suppose if there are two equal and opposite forces like this, FF, and passing through the same line, then the net force is zero and the net moment is also zero. So for a body to remain stationary, the net force should be zero and the net moment or torque should also be zero. But now that is not so. So there will be a torque like this. Suppose there are two equal and opposite forces. They are equal in magnitude and opposite in direction, but there is a separation between the lines of action. That will create a moment, and that moment is anti-clockwise. This is a vector quantity. Anti-clockwise is taken as a positive moment, and a clockwise moment is taken as a negative. That is just a tradition, a convention rather. Next, which of these is a vector? Well, work, power and energy are all scalar quantities. Moment of a couple is vector, and as I said, clockwise or anti-clockwise. Next, what is the correct energy transformation when a candle burns? The candle gives us heat and light, so the output definitely is heat and light. And it stores chemical energy. So option 3, output is heat and light and the input source is chemical energy. When a ray of light passes from one medium to the other, which of these quantities does not change? Well, if there are two different optical medium, then the speed changes. So speed cannot remain constant. If the speed is not constant, then the wavelength is not constant. The amplitude can change because the brightness can change. Amplitude relates to the intensity or brightness of the wave. So frequency does not change. Important to understand that the relationship between speed, frequency and wavelength. Speed is equal to frequency times wavelength. Frequency, who decides? The source decides. The medium has nothing to do with it. So when that light goes from one medium to the other, the frequency does not change. Next, which of these combinations is the correct ascending order of electromagnetic waves in terms of wavelength? So you should know the electromagnetic spectrum. The correct answer is 1, but let's see the EM spectrum, electromagnetic spectrum. There's a certain ordering, you see. We have gamma ray on the left and long radio waves on the right. Microwave in the middle, visible. This is the visible part that is there somewhere here. What is the ordering? If you go in this direction, then the frequency increases. And since speed equal to f lambda, The speed of all electromagnetic waves is the same in space, that is called c. So if the frequency is increasing, then the wavelength will decrease. So in this direction, the wavelength will decrease. So in this direction, therefore, the wavelength will increase. That's what is written over here. So therefore, gamma, visible, and microwave. By the way, gamma rays are also highest energy and long radio waves are the lowest energy. Why? You should know this. Energy of a wave is proportional to square of the frequency and also to square of the amplitude. For a lever, a graph is plotted with load on y and effort on x. What is the slope of a graph? Well, load by effort is mechanical advantage, isn't it? Load and effort are plotted here, and it is a straight line. The slope is the tan of this angle theta. Tan of this is perpendicular upon base, right? So perpendicular is load and the base is effort. So load by effort is mechanical advantage. Simple. If there's a real image formed by a convex lens and the ratio of I to O is 2:5. Now I is height of image and O is height of object. So we normally write HI for height of image and HO as height of object. That is given to be 2/5. What does it mean? Height of image is less. That means it's a diminished image, right? And it is a real image. So when does a convex lens produce a diminished image? For what position? That is beyond 2f. You should know this table. First of all, this diagram tells us this object is beyond 2f. I've drawn two rays. This ray is parallel, so it goes to the focal point on the other side. And this ray passing through the optical center goes undeviated. So those rays meet here. That becomes the image of A. The image of B is here. So the image of AB, this is the object AB, the image of AB is here. It is real because rays are actually intersecting, it is inverted, and you can see that it is diminished. So this table is important. There are 6 locations that we can think about for the object. For the first 5, if you look at it, the object is being brought closer from infinity and closer and closer. Then you see what is happening to the image. First it is diminished, then same size, then enlarged, then very large. That means the size is increasing as the object comes closer. That's what the table tells us. Next, deviation. There's an equilateral prism and a ray of light is incident perpendicularly. The ray gets totally reflected at the second refracting surface. What is the deviation? What is the meaning of deviation? The angle between two rays. Which rays? Between the final ray that comes out and the original ray which was incident. That is the deviation. So let's draw a diagram. This is 60 degrees and the ray is perpendicular, so it doesn't get deviated. Then it hits here. Then draw a perpendicular here. If this is 60, then this should be 30. So this is 60. Since it is being reflected, it goes off like this with this 60. Now, this is the original direction, right? So what is this angle? This plus this should be 180. So therefore, this is 60 degree, and the correct answer is 60 degrees. In a closed circuit containing a bulb and a cell, the EMF, electromotive force, and the terminal voltage are related as what? So guys, we should know one thing, that EMF E is equal to terminal voltage when the cell is not connected to anything, when the cell is not supplying any current. EMF is equal to terminal voltage. What is the meaning of terminal voltage, by the way? It is the voltage difference between the terminals. And both are measured in volts. Although EMF comes from a different angle and voltage comes from a potential difference comes from a different angle, but numerically they become equal. And therefore they are measured in volts. When the cell is supplying current, then the terminal voltage will reduce. See how? These are the two terminals of the cell. Internal resistance is small r and this is the EMF and it drives the current. The current is the voltage, the total voltage being supplied is the EMF divided by the total resistance, that is R plus R. So I can write I capital R plus I small r is equal to the EMF. Now, this voltage across A and B is also the voltage across the resistors, that is I capital R. Now, from this equation, I capital R is E minus IR. It is less, the terminal voltage becomes less. Why? Because there's a current being supplied and also because there's an internal resistance. If current was not supplied, then terminal voltage would have been equal to E. Also, if the internal resistance itself was zero, then the terminal voltage would always be equal to the EMF. And we say that an ideal cell is one which has got a zero internal resistance, ideally. But practically that is not possible. Okay, a metal piece of having some mass, 5 grams, has a thermal capacity so much. If the mass of the metal is tripled, what is the specific heat? Well, specific heat is what? Specific heat is written as C, is the amount of heat delta Q that you need to give per kg, therefore divide by the mass per Kelvin or per degree centigrade increase in temperature. So it is per unit mass. Therefore, specific heat capacity is an intrinsic property of a material, does not change with mass. So you might be confused. He's saying if the mass is tripled, what happens to the specific heat? That does not change, first of all. But yes, the question is what was the specific heat capacity to start with? So thermal capacity is also called heat capacity. It is also called heat capacity. That is equal to mass times specific heat capacity. So if you take mass this side, then you have MC is equal to delta Q by delta T, and MC is heat capacity, right? That is why this was joules per Kelvin, right? You can see the units, joule per Kelvin. So now from this equation, specific heat capacity is thermal capacity upon mass. Thermal capacity is 2.5 joules per Kelvin divided by 5 grams. So this will cancel 0.5 times. But gram remains at the bottom. So 0.5 joules per Kelvin was already there, but per gram will also come in option 4. Frequency, this is assertion reason. As the level of water in a tall measuring cylinder kept running under tap rises, the pitch of sound increases. Why? You see here. So we have a cylinder and some water is there and some water is being poured. So the sound is coming from where? The sound is coming due to this air length that is vibrating. It is air that is vibrating, and the frequency is always inversely proportional to the length. Which length? Length of the oscillating system. Water is not oscillating. It is air that is oscillating. So assertion is correct, but this reason is wrong. He's saying reason is frequency of sound is inversely proportional to the length of the water. No, it is actually inversely proportional to the air. You can say that as air increases, as water increases, the air decreases, right? So you can say that it is directly proportional to the length of the water. Yeah, but the statement is different. So option 3 makes sense. Now are these resistors in parallel? What is the meaning of parallel, guys? Meaning of parallel is you have 2 points, any 2 points, and you have a resistor. Another resistor comes in that is also connected between the same 2 points. This is what is called parallel. So if you see here, R1 is connected between these 2 points. R2 is also connected between the same 2 points. Here also, same 2 points between this point and this point. R1 is connected and R2. So therefore, they are parallel in both the circuits. Option 2. Periodic table. Suppose a radioactive element P emits one alpha particle and transforms to a new element Q. What will be the position? So what is alpha particle? Alpha particle is 2 protons and 2 neutrons. So when P emits alpha particle and becomes Q, that means Q will have 2 protons lesser than P and 2 neutrons also lesser than P. 2 protons means shifting to the left by 2 because periodic table is arranged in ascending order of atomic number from left to right, and proton means atomic number. So Z of Q, Z is the atomic number, is less than Z of P. So therefore 2 groups to the left of P, and this is the equation. P had some Z which is the atomic number and some A which is the mass number. Mass number is protons plus neutrons. So if you add protons plus neutron, that is 4. So A becomes 4 less and Z becomes 2 less. And this is what is alpha particle. Makes sense? Clear? I hope so. Alright guys, let's move to the next one. Each of these substances is supplied with the same amount of heat. Delta Q is the same, which will attain the highest temperature. The specific heat capacity is given. Now apply your mind. I told you that delta Q, I told you that C is equal to delta Q per unit mass per degree centigrade or per Kelvin rise in temperature. So delta Q is equal to MC delta T. Now for all these guys, we are giving the same amount of heat. So this is the same, right? And we have to assume that the mass is also the same, otherwise we can't solve. So that means for a high temperature increase, the C should be the smallest. So which is smallest? Lead is the smallest, you can see here. Lead is the smallest. Whosoever specific heat capacity is less, that will have the larger increase in temperature. This is a very interesting question on EMI. There is a copper ring and a magnet is dropped and a person is watching from here. As the magnet is dropped, there's an induced current in this copper ring. Question is, what is the direction? Now, this follows Lenz's law. So we can draw some field lines here, right? So this field lines are cutting. Now, as this magnet drops, the number of lines cutting this copper ring is going to increase. So we say that the flux is increasing while the magnet is above this ring. So there's a law called Lenz's law which says that the direction of the induced current opposes the very reason that created it. How will it oppose? By creating a flux. This flux is downwards, right? By creating a flux upwards. How will it do that? By creating a current that is anti-clockwise. That will create a magnetic field upwards and a flux upwards. And that means this behaves like a north pole and this behaves like a south pole. So that means while the magnet is above, seen from the top, it is anti-clockwise. And moment it crosses this line, that means south pole is there, now the flux is decreasing. So the induced current will oppose that reason. Therefore, it has to change its direction. It will become clockwise when the magnet goes below the ring. This is called electromagnetic induction, which is Faraday's law. And the direction is dictated by Lenz's law. Okay, that was question 1. Now 2 is fill in the blanks. In uniform circular motion, the centrifugal force acts towards or away or tangential, where centripetal acts towards the center. Centripetal means towards the center or seeking the center. Centrifugal is just opposite. So therefore, it should be away, correct, away from the center. Then refractive index of medium is independent of temperature. No, hot air, cold air, there's a difference of refractive index. Wavelength, no, refractive index depends on the color of the light. Color means frequency, frequency implies wavelength. It does not depend on the angle of incidence. So therefore, angle of incidence is correct. Heat absorbed during change of phase. For example, solid turning to liquid or liquid turning to gas. It depends on what? There is no change in temperature when the state changes. And specific heat capacity also is not involved. It depends on the mass. This is the expression. Delta Q is mass times L. What is L? Latent heat. Latent heat of fusion or latent heat of vaporization. EMF of a cell is greater than or less than to the terminal voltage. No, it is equal to, when the cell is in open circuit, then less than is not correct. It is equal to the terminal voltage. When the cell is in open circuit, means not supplying current. Okay, in a step-up transformer, the turns ratio is what? What's the meaning of turns ratio? Number of turns in primary divided by number of turns in secondary. If you want to step it up, that means the secondary voltage must be higher than primary. That is step up. And voltage that you get is directly proportional to the number of turns. Let me tell you something very interesting, that when you talk of a transformer, When you talk of a transformer, guys, per turn, voltage per turn is the same for both primary and secondary. So if you want a high voltage, you need to have higher number of turns, as simple as that. So step up means primary will have lesser than secondary, so less than. And nuclear radiation with the lowest ionizing power is gamma. Gamma penetrates very much but ionizes less. It is the most energetic, so it can penetrate even through ion, but it can't ionize too much. For ionization, you need alpha radiation. Good question on center of gravity. We have hung a kite which is of odd shape by a string. PQRS are 4 points. Which of them is likely to be the center of gravity? Suppose you take a body, a cardboard, let's say, and make a hole and hang it put a nail and hang it on the wall. And it is at rest. Now, center of gravity means the point through which the weight acts. The center of gravity must lie on this vertical line, somewhere here on this line, maybe here, maybe here. Why? Why not somewhere here? Because if the weight were acting from this side, suppose, then it would exert a moment about this force and therefore the whole thing would rotate. So the answer is R, isn't it? R is directly below that string. Okay, this is sound wave on a string. This is a displacement time graph. Question is, how will you adjust the tension in the wire to reduce the length of PR? What is PR? PR is on the x-axis. PR is time. It is some time, but within that time you can see one cycle is being completed. So PR implies what? Time period, isn't it? He is asking, you want to reduce the time period. Okay, so if you want to reduce the time period is the reciprocal of frequency. So if you reduce the time period, the frequency should increase. So how do you increase the frequency in a string? Well, you increase the tension. You increase the tension because I tell you why. The speed of the sound wave on a string is equal to square root of tension divided by mass per unit length. Mu is mass per unit length. If you increase the tension, then the speed will increase. So that is equal to F lambda. Now lambda is not going to change in that string, so F will also increase. So increase the tension in the string. And which characteristic of sound? Well, if you increase the tension, frequency increases, that means pitch is increased. Hope you're enjoying this. If you are, click on that like button and maybe put a comment. It takes a lot of effort to build this kind of videos, you see. But I'm enjoying it and hope you're enjoying it also. Now, this is a good question actually, guys. Please concentrate. A ray of light enters a rectangular glass slab submerged in water. So there's water and there's a rectangular glass slab. The ray of light is entering the glass slab from water. This is water. This is glass. Okay. Does this ray undergo total internal reflection when it moves from water to glass? Justified. The critical angle for glass-water interface is 50. Total internal reflection happens only when it goes from denser to rarer. But who is denser here? Who is denser? Water or glass? Look at the refractive index of water, that is 4/3 and this is 3/2. That is 1.33 and this is 1.5. So who is denser? Larger the refractive index, denser it is. So this scenario is rarer to denser. There's no question of a total internal reflection. So that is the justification for the answer. He is trying to confuse you by giving critical angle and all that. According to the new color convention, which color of wire? This is just information, okay? Metal body, what wire do you connect to a metal body? You connect earth. To the switch, you connect live. So earth is green and yellow stripes and live is brown. Neutral is blue. That is a new color convention which has been adopted internationally. Okay, AC. Which of the two, AC or DC, produces a varying magnetic field through a conductor? Now, magnetic field is written as B, and in all cases, this is proportional to the current. right? Now, if you change the current, the magnetic field will also change. So obviously, if you want a varying magnetic field, you should choose AC, because in AC the current magnitude and direction changes. In DC it does not, right? So AC is the answer for A. And what is the frequency of AC in India? That is 50 hertz. In some countries it is 60 hertz. Calculate the amount of heat absorbed by 200 gram of paraffin wax to melt completely at its melting point. Guys, first of all, the concept is when the state changes, the temperature does not change. The temperature remains constant. So the heat that you're supplying, that energy that you're supplying, where does it go? It goes in separating the molecules. From solid to liquid, the distance between molecules is increasing and they are attracting each other. So you're separating them, you have to do work, and that is where the energy goes. So during a change of phase, the temperature is not involved, but it will only happen at a certain temperature. Melting will happen at the melting point. So delta Q in such cases is mass times L. This L can be either latent heat of fusion or latent heat of vaporization. Fusion is used for solid to liquid conversion and vaporization for liquid to gas. So this answer is very simple. Just multiply mass with latent heat. Mass is 200 grams and latent heat is 146 joules per gram. Gram cancels. This into this is 29,200 joules. Very simple question. Solenoid. Copper wire is round around a steel bar FT. Current is allowed to pass through the coil for some time and then the bar is removed. Now this current that you see, is it AC or DC? It is DC because battery only supplies DC current. The bar FT is made of ferromagnetic material, steel, so it gets magnetized. So we have to draw the magnetized bar and mark its poles. It will be like this. I'll tell you why it will be like this. Why is this side a north pole? Well, if you see this turn from the left hand side, the current is going anti-clockwise, right? The current is going anti-clockwise, right? This one, it is going anti-clockwise. So that is the north pole. If you see from this side, the current is going clockwise, that is the south pole. That is why. North-south. So we have to draw some lines, magnetic field lines outside the magnet go from north to south. So I've drawn north to south. But inside also they are there. Inside the line goes from south to north. So magnetic field lines form closed loops. Very interesting. Unlike electric field lines which do not form closed loops. Effect of temperature on resistance. A current flows through a metallic conductor for a long period of time. What is the change you would expect? Well, temperature raises the resistivity and therefore the resistance. So both of them will increase, right? The expression for resistance is resistivity times length divided by the area. If resistivity goes up, resistance will also goes up as long as length and area are the same. So there's a quantity called alpha, which is the temperature coefficient of resistivity, which is the change in resistivity per unit resistivity per degree centigrade or per Kelvin rise in temperature. So therefore, delta rho, the change is rho alpha delta T. Change. Therefore, the final rho at any other temperature, you started with T naught, now you raise the temperature. So this was a rho at temperature T naught. This is a rho at temperature T, and T is more than T naught. This is actually rho at T naught plus the change, right? So when you add the change here, you can take rho T naught outside is 1 plus alpha T minus T naught. This is a very good question. Curium is a radioactive element with the symbol 24796. Named in honor of Madame Curie, the graph of protons versus number of neutrons for some elements are shown below. Number of protons, that is P, and this is number of neutrons, N. Now this number, when you say 24796, then this is the number of protons. This is not the number of neutrons. This is proton plus neutron, right? Last number. Which point on the graph indicates? So 96 is the number of protons, but is it R, Q, or P? What is the number of neutrons? If you subtract 47 minus 96, what do you get? 7 minus 6, 1, 14 minus 9, 151. So 151 is here. So therefore, P represents that element. Clear? B. Which point on the graph indicates the daughter nucleus after it undergoes radioactive decay of 1 alpha followed by 2 beta? Beta is an electron, and this beta radiation happens when a neutron converts to proton. Neutron converts to proton plus an electron, and this electron is called the beta particle. And alpha, of course, is 2 protons, 2 neutrons. So let's go step by step. If 1 alpha comes out, when 1 alpha comes out, 2 proton and 2 neutron are gone out. So what happens to the Z of the curium? Z was 96. It was 247.96, right? And that means the neutrons were 151 and the protons were how much? 96. This is the start point. Now, if 2 protons gone, this has to become 94, right? And if 2 neutrons gone, this has to become 149, isn't it? So this is a picture when 1 alpha goes out. Now, if 1 beta goes out, what happens? That's very interesting. 1 beta goes out, a neutron is converting into a proton, correct? And if 2 beta goes out, then 2 neutrons will become a proton. So 2 out of this are shifting this side. So that means this will go back to 96 and this will become 147. 96, 147. So if you add it up, 3 carry 1, 243. The mass number is 243. Which point? Proton is 96. So either R or Q. If you look at the number of neutrons here, it is 147. So answer is R. Clear? The mass number, of course, is 243. So you've got to be very careful when you have multiple radiations coming up. Go step by step. It is always advisable to write down the numbers initially and after each radiation, what happens to that number. That is the methodology aspect I was telling you. This is not random. Whatever you want to do, you can do. Out of the 3 rays, IJH, shown in the picture, which ray will suffer total internal reflection? Critical angle is 42. When do we have total internal reflection? When the angle of incidence is greater than the critical angle written as theta c. That is when we get the total internal reflection. So let us look at each one of them. You see, suppose I talk of J. J is coming and hitting straight this point because hitting perpendicularly means not bending, hitting. What is the angle of incidence? You draw the perpendicular at the angle of incidence. This is the point of incidence. Draw the perpendicular at the point of incidence. If this is 60, then this should be 30. Therefore, this is 60. This 60 is more than critical angle. So therefore, this suffers total internal reflection. What about H? H will hit and go directly and hit this point. If this is 30, then this is a normal at the point of incidence. This is 30. So this is less than the critical angle. It won't suffer total internal reflection. Similarly, I is also hitting at an angle of incidence 30 degrees. So J is the answer. Then copy this diagram to complete the path. Okay, let's complete the path. We are talking of J. It came perpendicularly. It hit this point. The normal is this one. If this is 60, then this is 30. Therefore, this is 60. Greater than the critical angle, so therefore it does a total internal reflection with angle of incidence equal to angle of reflection comes in here. Now what is angle of incidence? This is 60, this is also 60, parallel lines. This is 30. 30 is less than the critical angle. Therefore it will not do a total internal reflection here. It will go out, and since it is going from glass to air, it will bend away from the normal. And we can calculate this angle also if we know the refractive index. If you have your concepts very clear, answering these questions will be a breeze. But if you don't have your concepts clear, you'll have to struggle. Okay, this is also on refraction. A rectangular glass block of refractive index 1.5 has an air bubble here. And this distance is 15 centimeter. When seen from the surface AB, somebody is seeing from the top like this, it appears to be 4 centimeter deep. It appears. So what is this 4 centimeter? This is the apparent depth. Appears, right? What is the actual depth? What's the relationship between real depth and apparent depth? Refractive index is equal to real depth by apparent depth, right? So 4 centimeter was the apparent depth. Let's say D is the real depth. D is the real depth. So N, which is 3 by 2, is real depth by apparent depth. Real depth is D. Apparent depth is 4 centimeter. So 2 will cancel with this 4. 3 into 2, 6 centimeters. The answer for D. So this is 6 centimeter. All right. This is a real depth. For which color of light, blue or yellow, the apparent depth will be greater? If I write apparent depth now, is real depth upon N, right? Correct? Now, real depth is not changing. We are only changing the color, right? Blue or yellow. So, what is the dependence? You should know this. Let me write with your violet, indigo, blue, green, yellow, orange, red, right? This red and this violet, if I compare the refractive index, the N for violet is greater than N for red and applies equally for all the colors in between. So if you look at blue and yellow, the N for blue is greater than N for yellow. So if N is greater, then apparent depth will be smaller. But we want apparent depth greater, that means N should be smaller, right? That means yellow. Answer is yellow. Okay. And then turning the glass block upside down does not change the apparent depth. True or false? No, it is false because this distance is 9 centimeter, right? And now you are watching from here upside down. So if the real depth has changed, then the apparent depth will also change. So this is false. Convex lens, an object is placed at 2F position. Draw a ray diagram. That's very easy. 2F position. We need only 2 rays, right? One ray I have taken as parallel, so it goes to the focal point. Another ray going through the optical center does not get deviated. The image of A is here. Image of B must be on this line. And then the size of this image is exactly the same as the size of the object. Question is, how will the size of the image change if we only replace the lens with another lens of greater focal length? So if this lens was changed for a greater focal length, nothing else is changing. That means this position is no longer 2F, right? Is no longer 2F. Focal length is increasing, right? But this distance is not changing. So that means the new focal point, this was F1, the new focal point may be somewhere here, and the 2F may be somewhere here. So now the object is either between F and 2F or between F and O. The object distance will be either between F and 2F or between F and the optical center. Then the image becomes larger. Refer to the table. Refer to the table, right? Also, the characteristic changes if the object is between F and O. But we don't know how much is the increase in the focal length. So all that we can say is that the image will become larger. This is definite. But whether it will be real inverted versus virtual erect, that we can't say. Using lens formula. Now, this kind of question should be really on your fingertips. The only thing you have to be careful about is the sign convention. With a concave lens, and object distance is 45 centimeter, image distance is 30 centimeter. What is the focal length? Just apply lens formula. What is that? 1 by V minus 1 by U equal to 1 by F. But sign convention is important. What is the sign convention? Let's talk about that. So, suppose I have a concave lens, right? This is the optical center. All distances are measured from the optical center, everything. So suppose an object is here, right? You want to measure this distance. You start from the optical center and go this way. Now, this distance will be some number, let us say 10 centimeter, let us say, will it be plus or minus? Well, you are going in this direction, the incident ray is in this direction. If you are going against the incident ray, this will be negative. If you are going along the incident ray, then that will be positive. Furthermore, if something is above like this, then that distance is positive, and some distance is below, that distance is negative. So therefore, object distance is minus 45, and B is 30. How did I say minus 30? That's very interesting. How do I say minus 30? Because concave lens always produces an image on the same side. That you should know. Therefore, P is minus 30. This you should know. How did I put minus? Now applying this, 1 by minus 30 minus 1 by minus 45 is 1 by F. Now after that is a very simple calculation. We get F as minus 90. Remember, or not remember actually, note that focal length automatically turns out to be negative. For a concave lens, the focal length is negative. So what you have to remember is that when you have an unknown quantity, do not put a sign from your side. Let algebra give you the answer. Everybody knows that the focal length will be negative, but don't write minus f here. That will be wrong. Algebra will give you the answer. That is a lesson, guys. This is where people make mistakes, and then they say problem solving is a problem. Okay. Again, on refraction, two rays PQ and RS are incident on a rectangular glass block. Which of these rays will have a greater lateral displacement? You see, angle of incidence is the same for both of them, but this angle and this angle are different. Angle of refraction is smaller. The angle of refraction for RS is smaller. That is the difference. So, if R is smaller, that means it is bending more. The ray is bending more. Bending more means refractive index is larger. So which of these will have a greater lateral displacement on emerging? Let's draw a simple diagram. Let's draw a simple diagram. I have an incident ray. If you look at the black one, then it comes and hits here, then comes out. The lateral displacement is this much. Now suppose I take the yellow ray, which bent less. It bent less. So the lateral displacement of the yellow one is less, right? So which of these two will have a greater lateral displacement? The guy who bent more, the guy who bent more would have a greater lateral displacement R. Then which will travel with a greater speed? Greater speed means refractive index, okay, and speed are related. What is refractive index? N is equal to C by V. Speed in air divided by the speed in that medium. So he's asking which will have a greater speed. For greater speed, smaller refractive index. Correct. So who is bending less? That guy will be having a lower refractive index. So P is bending less. And which will scatter more? Well, the relationship between wavelength and refractive index is important. Smaller the wavelength, larger the refractive index. Again, if I talk of Vibgyor guys, red is 700 nanometer wavelength and violet is 400. Others are in between. So red is larger wavelength, right? Violet has got a lower wavelength and a larger refractive index. So we say N for V is greater than N for red. Smaller the wavelength, larger the refractive index. So R has got a smaller wavelength because it had a larger refractive index, and that will scatter more. Smaller wavelengths tend to scatter more. I must tell you something additional. It may not be there in your textbook. The scattering relates to the wavelength like this, 1 by wavelength to the power 4. This is called Rayleigh's law. If the wavelength is small, then the scattering is high. Got it? EM waves. Name, this is very simple. Name for which a quartz prism is used to study the spectrum. Well, that is ultraviolet. And what is used for remote sensing devices? Infrared. By the way, your television remote is also emitting infrared. What is used for traffic signals? Obviously, visible spectrum. And what is one common property to all electromagnetic radiations? Not frequency, not wavelength, speed. And that also speed in air or vacuum. In any other medium, the speeds of different colors are different. As we know, the refractive indices are different. Principle of moments. Akash takes a uniform meter scale, that means 100 centimeter long, right? Suspends a weight of 2 Newton at one end x. You see, I'm following the methodology, right? I'm reading the question and understanding it. Don't rush through it. suspends a weight of 2 Newton at one end x and a weight of 5 Newton at another end y. He then balances the ruler horizontally on a knife edge placed at 70 centimeter. Draw a diagram and calculate the weight. So let's draw the meter scale. The whole meter scale from here to here is 100 centimeter. At x he has hung a 2 Newton weight. At y he has hung a 5 Newton weight. What about the weight of the ruler itself? It will act on the center of gravity, which is right at the center at the 50 centimeter mark. That is the weight. Then he has put a knife edge at a distance of 70 centimeter from x. We have to now calculate the weight of the ruler. Look, this scale is at rest, right? So what are the two rules? You tell me. Oh, I can't hear you. So now you think about it yourself. If a body is at rest, two conditions should apply. One, net force is zero in any direction and net moment is zero about any point. About any point. So let us take the moment about this point. We don't know the force being exerted by the knife edge. This N is a normal reaction from the knife edge. We don't know. But if we take the moment about this one, the contribution of this N will be zero, and therefore I don't even need to know what is N. Now this 2 Newton, about this will be 2 Newton into 17 centimeter. This will exert an anti-clockwise torque. Weight will also exert an anti-clockwise, but this one, about this point, will exert a clockwise torque. Net torque zero means the sum of clockwise torques will be equal to sum of anti-clockwise torques by magnitude, equating the torques. 2 Newton into 70 centimeter plus weight into 20 centimeter, these are anti-clockwise, and the clockwise is 5 Newton into 30 centimeter, cancels throughout, and a simple calculation gives me the weight, 0.5 newtons. Clear? Principle of moments. Lever. Equal lengths. Which class? I'll tell you class-wise. Remember FLE. F-L-E. Fulcrum load effort. And just write FLE. If fulcrum is in the middle, then it is class 1. If load is in the middle, then it is class 2. If effort is in the middle, then it is class 3. So here fulcrum is in the middle, so it is class 1. Among X, Y, or Z, which one will give the maximum mechanical advantage? Well, if you think of the torque about the fulcrum, then load into load arm must be equal to the effort into effort arm. See here. This is, if I call this effort, this is the effort arm and this is the load arm. So the torque of this load about the fulcrum is load into load arm, and similarly for the effort. They should equalize if the thing is in equilibrium. So effort into effort arm is equal to load into load arm. Mechanical advantage is load by effort. So therefore, from this equation, load by effort means effort arm by load arm. If this has to be greater than 1, then effort arm should be greater than load arm, and therefore this is the correct answer. In this drawing, the effort arm is the longest. Correct? Work energy principle, Richa, where weighing 40 kgf. What is the meaning of 40 kgf? That her mass is 40 kg. Leaves the point P and slides down this slope and comes to Q and then to R. She leaves point P, that means the initial speed is 0, and reaches point Q on the ground with a speed of 10 meters per second. That is what is given. What is the kinetic energy? Well, that is half mv square, right? So first of all, 1 kgf means what? Weight of 1 kg mass. And 40 kgf weight means mass is 40 Newton, 40 kg. So kgf is not an SI unit for weight, for force. Newton is. So what is the weight of 1 kg? Weight of 1 kg is mass into g. This is 10 newtons, right? Ke, kinetic energy is half mv square, half mass is 40 kg, and v is 10, so 10 square. This cancels 20. 20 into 100 is 2000 joules. That is part A. Then vertical height of point P above ground. Well, we can apply kinematics equation. The acceleration is constant, so we can apply the equation of motion. Using v square equal to u square plus 2as, u is 0. Applying for the b part, u is 0. And the final velocity here is 10, so 10 square, 2as. We are taking g as 10. So 10 and this S is the vertical height, not this, not this. When a body falls, whether vertically downward or through a slope, it doesn't matter. You have to just take the vertical height as long as friction is not active. The question is saying that neglect friction. Therefore, we will just take the vertical height. So 2 into 10 into h. This is 100. This is 20. So h is 5 meters. The next question, friction is there. What is the kinetic energy of Richa at the point R? While moving from Q to R, there is friction. And she loses 500 joules. So let us calculate without friction first. That will be easier. For QR part, let us calculate without friction. Then we will factor in the friction. See here. Using this equation, the U for the QR part, it is like this. Q is this, R is this. The U was 10 meters per second, right? We don't know what is the speed here. So 10 square plus 2. Now the acceleration I'm writing minus 10 because it is a retardation. Okay. And the S, this height is given to be 3 meters. Again, vertical height because I am neglecting friction right now. So how much is this? 100 minus 3 into 2, 6, 60, 40. This is V square. So it is 40 meter per second whole square. So the kinetic energy is half mv square, half m is 40 and v square is 40. So this cancels 20, it is 800. Out of 800, she loses 500. Therefore, her KE is 300. You could solve it by just applying KE potential energy concept and also work done by friction. That's an alternate method. Draw a block and tackle system with velocity ratio equal to 3. So I'm drawing it, then let's talk about it. This is 3. Why? We normally assume that the string is ideal, so the tension is the same throughout. So whatever effort is applied, the same tension is created. Now same T goes all around. Tension is a pulling force. You cannot push a guy with a string, you can pull him with a string. So wherever there's a string attached, the tension will be acting outwards. So if I look at the bottom part, which is a load, the tension is acting upwards. And there are 3 strands supporting the load, right? The load is here, the 3 strands. And each is having tension T. If it is at rest, then the 3T must be equal to the load. Whereas the effort is only T, because whatever effort you apply, the same tension is created. Effort is T, load is T, mechanical advantage is effort by load, 3T by T, 3. Now, MA by VR is equal to efficiency. Assuming efficiency is 100%, that is 1, then VR, velocity ratio, will be equal to MA, and that is 3. If nothing is specified, we assume 100% efficiency. Sonar. Sonar means sound, navigation, and ranging. This is submarine. This is very easy actually. Sends an ultrasonic ping. Ultrasonic means what? What is the difference between ultrasonic and supersonic? Supersonic is something that travels with a speed greater than the speed of sound. Ultrasonic means very high frequency. What high frequency? Greater than 20 kilohertz. Why 20 kilohertz? Because that's what we can hear, human beings. More than 20 kilohertz we can't hear. So submarine is sending ultrasonic ping and a stopwatch is started simultaneously. The stopwatch stops on receiving the reflected wave from an obstacle. And the time taken for the wave to come back is so much. What is the distance of the obstacle? Speed of sound is given. Well, let's draw a diagram. We have a submarine, we have an obstacle, and the distance between them is d. A sound wave is sent, it goes here and then reflects and comes here. The time taken for that is 1 minute 40 seconds, that is 100 seconds. But what is the distance traveled by the sound? It is not d, it is 2d. So 2d is the distance is equal to speed into time. Speed is 1500, time is 100. So divide by 2, you get 750 into 100, that is 75,000 meters or 75 kilometers. This is on resonance. We have 2 sound boxes A and B with wires of the same length and tension. Tension is due to this 10 kg of weight hanging. Same tension, same length. That means this length between the 2 supports, this length, L. Okay. but the cross-section areas are different. Simultaneously, vibrating tuning forks of frequency 300 Hz are placed on the boxes. The paper rider that is kept in between both of them, right? The paper rider falls off in B but not in A. Why does that happen? Because of resonance. Wherever resonance occurs, the vibration amplitude goes higher, therefore the paper rider goes off. And resonance occurs when the external frequency of that fork matches with the natural frequency of the string. So what is the phenomenon? Question A is resonance. Okay. Now the wire A is resonating with the tuning fork of some other frequency F. Is F greater than or less than 300? Justify. So let's talk of that. Okay. Let's talk of that. First, let's talk of resonance is a special case of force vibrations. When the frequency of an externally applied periodic force is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. Now, second part, this A is going to resonate with less than 300. Why? Applying B equal to F lambda. Lambda is the same as, because the length is the same. So lambda is the same, right? Now, the frequency will be proportional to V, and V is root T by mu as we just saw. Now, A, if you look at the question, different cross-sectional areas, right? Paper rider falls off in the case of B and not A. So that means A should be having a greater cross-section area, greater mass. So mass per unit length is more. So the speed is less. If this is more, this will be less. If this is less, this will be less. Therefore, less than 300. Household wiring. What is the current rating of the device X? What is this device X? It is a fuse. And that is the pole, the fuse on the pole. What is the rating of that? Well, it depends on the load that particular pole is serving. It will be serving multiple houses or multiple buildings. The rating would depend on how many houses it is building. Load. Load in electrical engineering means current. Okay, how much current? Excess current means excess load. Well, this fuse rating is typically around 50 amperes. B, what is the difference between the switch Z that you see over here versus the switch that you use at home? This is called double pole. Now you see here, this is actually the live one, right? This is the neutral. Current enters through the live and returns to the neutral. And this is the earth. Metallic body is connected to the earth. And this symbol is the earth symbol. So this is live, this is neutral, right? And there are two simultaneous things that will close down when you press it, right? So the difference is that it engages live and neutral together. But in the case of our homes where we have a simple fan and all that, it is just like this. There's a switch like this, and this is live. You close this, the bulb that is there over here will start to glow. It is engaging only L. And this is the meter. You pay for the electricity that you use, so that is energy, that is kilowatt hour. That is a physical quantity displayed in Y, and that's energy, kilowatt hour. Watt hour, power is energy by time, isn't it? So power into time is energy. Kilowatt into hour is energy. You pay for the energy. All right, nuclear fission, study the diagram and answer the questions. There's a neutron coming and hitting this uranium, then becoming something else, and then breaking off. These are called daughters. Daughter nuclei, there are two daughter nuclei. I don't know why they are not called son nuclei, but they're called daughter nuclei. So two daughter nuclei come out plus something else and plus a lot of energy. What is the process? Fission. Fission is breaking. What is the value of X here? Well, simple. One neutron is getting added, so 235 will become more, so it is 236. Let us write the equation. We have 236U breaking into 14456 barium and 8936 krypton plus 3Y. Now the numbers must match on the left hand right hand side. The energy is being released, but the numbers must match. So if I talk of protons, 92 must be equal to 56 plus 36 plus 3Y. But 56 plus 36 itself is 92. That means this doesn't contain any protons. Why doesn't contain any protons? If I talk of neutrons, neutrons here is 236 minus 92. Neutrons here is 144 minus 56. Neutron here is 89 minus 36 plus this 3y. So here we have 144 is equal to this much is 88 and this much is 53 plus 3y. This much is 141. So therefore 144 equal to 141 plus 3y. So that means y is equal to 1. That means it's a neutron. There was no proton there. It is a neutron. That's what typically happens in a nuclear fission. 2 or 3, on an average 2.5 actually. On an average 2.5 neutrons also come out. Electrical circuit, very simple. 3 identical bulbs, B1, B2, B3, each of power rating 18 watts, 12 volt, are connected to a battery of 12 volts as per the diagram, right? What is the resistance of each bulb? What is the current drawn from the cell? That's very easy. Resistance. Well, you know, power is V square by R. First of all, I can write power in 3 ways. Guys, power is actually voltage into current. So V is equal to IR. If I replace I, that is V by R, then it becomes V square by R. If I replace V as IR, then becomes IR into I, that is I square R. So there are 3 different ways of writing power. In this case, I'm using this P equal to V square by R. So R is V square by P. What is V? 12. What is power? 18. So 12 into 12 by 18 gives me 8 ohms. So each is 8 ohms. Okay. That's a resistance. Then what is the current? What is the current drawn from the cell? That will be depending on the total resistance of the circuit. So it is 8 ohm plus 8 ohm in parallel with 8. Guys, if you have 2 identical resistance in parallel, then the effective is half. You should know that. So 8 plus 8 in parallel with 8, that is 8 plus 4, that is 12. Effective resistance is 12 ohms. Battery is 12 volts. So the current is 1 ampere, 12 by 12. Now, if the bulb B3 is removed, if this is knocked out from the circuit, what will happen to the brightness of B1? Well, brightness depends on current. What will happen to the current? If you knock out this one, then the resistance of this part of the circuit goes up, not down. Guys, 8 in parallel with 8 was equal to 4, right? Now it is only 8. This has been knocked out. So the resistance of the circuit is increasing. The current supplied by the battery is decreasing. So therefore the bulb will glow with lesser brightness. Lesser brightness. Calorimetry, 30 gram of ice at 0 degrees is used to bring down the temperature of some mass of water from 70 to 20. What is the mass of water? We have to assume that finally they come to equilibrium temperature of 20 degrees. In calorimetry, we should go step by step. What is the step? Ice will first melt. But when it melts, it is still at 0 degrees because it was starting with 0 degrees. Temperature does not change. And then it goes to 20 degrees, right? So if you look at heat lost by water to go from 70 to 20 is mc delta T. C is 4.2 joules per gram per degree centigrade, right? And this mass we are going to write in grams. So therefore gram will cancel. This is 210 into m joules. Water is losing. Ice is gaining, but in 2 stages. Heat gained by ice while melting is ml, mass is 30 and latent heat is 336 joules per gram. So that is so much. And then second step is going to 20 degrees. Now it is water, it's not ice anymore. So it is mc delta T. It is not ml now. When the state does not change, it is mc delta T. When the state changes, it is ml. So C of what? C of water. It is not ice anymore. Delta T is 20, so we get this. Now we apply the principle of calorimetry. Heat gained is equal to heat lost. So 10,080 plus 2520 is the net heat gained, and the heat loss was 210 m. So that gives me m as 6 grams. All right. Again, I missed an A over here. Specific heat capacity. A certain amount of heat will warm 1 gram of material X by 10 degrees and 1 gram of material Y by 40 degrees. Which material has higher specific heat capacity? Simple, we have discussed this 2 or 3 times now. Delta Q is MC delta T if the state is not changing. Now he's saying same heat is same 1 gram. So these two are same. So temperature rise is different though. So if the delta T is higher, that means C is lower and vice versa, right? So who has got higher specific heat capacity? And see for X, the change in temperature is 10. For Y, it is 40. The delta T for X is lower, so the C of X is higher. That is the answer. B, which material should you use to make a calorimeter? We should use one with a lower heat capacity. Therefore, we should use Y. And then specific heat of a substance remains the same when it changes state from solid to liquid state. Straight true or false? False. Ice melts to water, for example. The specific heat of ice is not the same as specific heat capacity of water. So it is false. Last question. This is about force. There's a magnet and then there's a copper rod PQ, and you can see the battery the way it is connected now. What will happen to the rod PQ? Will it move to the left or to the right, towards C or towards A? We have to use Fleming's left-hand rule, right? Let's look at the direction of current. This terminal is positive, this terminal is negative. So current will be from positive to negative. So it goes like this, then goes like this, then like this, and enters, right? That's the direction. So in the rod, the direction of current is this way. And the magnetic field is from north to south. As I told you, outside the magnet, it is from north to south. The magnetic field is downwards. Current is this way. Applying Fleming's left-hand rule, is motion, and the index finger is magnetic field, and the middle finger is current. And you've got to place these 3 fingers mutually at right angles. So in this case, the current direction is into the plane of the board. So you take your middle finger and point it towards the plane of the board. But the magnetic field is down. So your index finger must come down. The thumb will be pointing this way. So therefore, that is true. The law that is used here is Fleming left-hand rule. What will be the effect on the force if the rod PQ is replaced by another copper rod of same length but of greater cross-section area? If resistance is rho L by A. Other things remaining same, if you increase the cross-section area, the resistance will drop. So lesser resistance means higher current. Higher current means higher force. So that was the entire chapter. I hope you not only enjoyed the entire session, but also learned a lot of good new things. How to solve problems. Some of your concepts should have become stronger. Therefore, give a like, give a comment, and subscribe to the channel. Thank you for watching. Bye.